Welcome to Team 32's interim presentation by William, Asha, Austin, Ben, Jason, and Sumika about hair dryers. A hair dryer, also known as a blow dryer, is a device that uses electrical and mechanical processes to blow ambient or hot air. The air blown over the wet hair accelerates the evaporation process. The hair dryer consists of an electric heating element in the form of a coil and is powered by an electric motor and fan that blow the air. The heating element is held in place by an insulator and positioned within a heat shield. The device provides multiple modes to control both the speed of the air and the temperature. These modes enable the customer to obtain the desired hairstyle. Cool air helps reduce frizz and promote shine, while hot air speeds up the process. The primary customer's hairdryer comes with a unique attachment, a flow concentrator. The concentrator makes the end of the hairdryer narrower and thus concentrating the heat to dry the hair more rapidly. That product is shown at the right. The two target customers, primary is the individual retail customer, secondary is businesses such as hotels, barbershops, and hair salons. The estimated potential volume for those customers is 388,000 units a year, estimated from Statista.com. That's 2% of the total sales in 2023, which was 19.4 million. The differentiation in the product for the primary customer is that it provides them with the unique attachment and also multiple colors that help conform to their personality, while the businesses want a cheaper, simpler product without that attachment. Here you'll find the exploded view with the parts labeled and a list of all the parts in the assembly. Here is our fast diagram. The main functive is to dry hair, and we broke that down to the leaves on the right. Here is one of two assembly sequences. From left to right is the product being assembled over time. We start with the front enclosure, add the front net, add a small subassembly consisting of the zigzag heater wire, heater ribs, heat shield, a second small subassembly of the motor, motor housing, fan, and motor assembly carrier. Next, the power knob, heater knob, speed knob, the last subassembly being the back enclosure cover, back cover, rear enclosure, and lastly, the unique attachment. Here is the second assembly sequence we created. The difference is that the subassemblies are broken down and added as individual parts. This is a comparison of the two assembly sequences. You'll see that sequence 1 is better than sequence 2 due to the ease of fastening and joining, ease of testing subassemblies, and ease of assembling in parallel. Here is our functional component mapping matrix. The columns are from the fast diagram leaves. The rows are from the parts list. You'll see that the screws have been removed as they do not provide any of the functions and will be optimized out later in the project. You'll also see here that the rear enclosure and rear enclosure cover perform the same functions and thus can be optimized. That, along with the heater ribs, all three provide the same functions and can be optimized as well. Here's the BOM cost estimation. This was based on the 388,000 units a year, a manual assembly process. You'll see that most parts are injection molded, while some use metal forming processes. The total is $20.95, which does align with about 50 to 70% of the cost of hairdryers in the market, even though you'll note that the prices do vary substantially from hairdryer to hairdryer. Here, we looked at the functional importance and the cost of assembly. The parts with low importance and high cost, being the motor assembly and motor housing, will be optimized later in the project. We'll also look at optimizing the low importance parts in the top left box. Here is the product family design overview. The differentiating function is the guide airflow. That is provided by the module being the unique attachment added at the end. These are also differentiated by the color of the modules on the right for the rear enclosure, back cover, and the three knobs. Here are the module interfaces for both the primary customer and the secondary customer. The primary customer has a unique interface between the rear enclosure and front enclosure, which is assembled via two screws. The secondary version you'll see does not have the unique attachment, and that interface is a press fit. Here is the product family design assembly sequence. It is hard to see the difference at first, but you'll find that it is in how the subassemblies are added. You can see that via the dotted lines. You'll find that we split the process when we get to the colored parts, which are the pink, red, and green. The last difference is in the unique attachment added at the very end for the secondary customer and not for the primary customer and not for the secondary customer. Thank you for your time. Sincerely, Team 32.